Okay, this is the P4 paper from October 2021. Question number 8, and as we can see, this is an integration question. We're going to have integration by parts here, and we're going to have finding the volume of revolution about the x-axis for the second part. So let's look at 8 part A first of all. 8 part A says, can we find the integral of x squared log x dx? And really, if you've been working hard enough, guys, this should not be difficult at all for you to recognize straight away. This is integration by parts, and it's integration by parts where we have a log function as part of our integration by parts. So normally we take u as being x squared and dv as being whatever the other part would be, but no, we don't do that. If log's involved in it, then that has to take priority, and I'm going to say u is equal to log x, and I'm going to say dv by dx is equal to x squared. Okay, differentiating u, du by dx is 1 over x, and integrating dv, integrating x squared is x cubed over 3. The whole idea then of integration by parts is that we have the integral of u dv dx with respect to x is equal to uv minus the integral of v du by dx. So we're simply subbing everything into the information there. The left-hand side obviously is going to be the question. So we get integral of x squared log x dx is equal to uv, those two, minus the integral of v du, always tends to be those two. So doing that, uv is log x times x cubed over 3, but I'm going to write that as x cubed over 3 log x minus the integral of, and then we've got 1 over x multiplied by x squared over 3 dx, and now when we do that, then that becomes x cubed over 3 log x minus the integral of x squared over 3 dx, and then we can just integrate that. X cubed over 3 log x, integral of that, add on to the power divided by the new power, minus x cubed over 9, and then obviously don't forget our constant of integration in for the final part of that. So integral of x squared log x, no problem at all. Let's look at the second part then. Part B says the area R, which we've got here, is going to be rotated through 2 pi around the x-axis. We're going to get this sort of cone-looking shape here, this 3-dimensional shape, if I've got that, and the integral of the volume is going to be the integral between E and where? Okay, well, let's call this x1, between E and x1 of pi y squared dx. That should not be any sort of surprise to you. You should have no problem understanding that. So what that does mean is we've got to find x1 before we can get going with that, and then let's see what we've got as the integral. So for B, find where curve hits the x-axis, and that's x log x. So where is x log x equal to 0? If x log x is equal to 0, I get either x is 0 or log x is 0, which is going to give me x is 1. So going back there and just checking on my diagram, yeah, that makes sense now. This value is 0, this value is 1. So the volume of revolution I'm interested in, so volume is going to be equal to the integral between E and 1 of pi y squared dx, which is going to be, we'll take that pi out, between e and 1. Y squared then is x log x squared dx, which we can write down as pi e1 x squared log x squared dx. So let's have another go at using integration by parts to do this one then. So we're going to set u as equal to our log x squared, and dv by dx is going to be equal to x squared, differentiating log x squared. So basically, treat this thing like something squared. If you're going to differentiate something squared, you do differential of x squared is 2x. So it's going to be, it's going to be 2 log x, but then multiplied by the differential of what's in here. So multiplied by the differential of what's in here, multiplied by 1 over x. If that's causing you a problem, then you need to spend a little bit more time before you come back and do any more of these integration by parts question. That really should be something that doesn't cause you any issues at all. Same with integrating this, add 1 onto the power divided by the new power, means we're going to get to that situation. And then just like we did last time, let's say, okay, so integration by parts says the integral of u dv dx is equal to uv minus the integral of v du dx, but now we can actually put limits in, so I won't have a constant of integration. So if I'm doing that, then that's going to give me uv, u and v are those two. So I'm going to have x cubed over 3 log x squared. All of that's going to need to be evaluated between e and 1 minus the integral of v du by dx, which is these bottom two, v du by dx. And again, trying to tidy that up a little bit, so that's going to be x cubed over 3 multiplied by 2 log x multiplied by 1 over x dx. We just need to take time now and going to the next line down and saying, right, well, what have I got? Well, I'm not going to do the E1 yet. I'm not going to do the square bracket thing. I'll do it all together. So just leave that as it is. Don't do anything with that yet. That's going to be between E and 1 minus, let's tidy this other bit up. So I could take 2/3 out of the integral sign, and then the x cubed and the 1 over x, that's going to cancel down to x squared log x dx. And then absolutely at this stage, that's a real relief to me. I get x squared log x, and then you think, right, okay. That's why I was doing that top part up there then. So it now makes sense to me that the two parts of the questions actually combine together here. So this is then x cubed over 3 log x squared, and then that's between e and 1 minus 2/3. We now know this is x cubed over 3 log x minus x cubed over 9. And that thing can all be done between e and 1. So I can combine those two together now, can't I? So I can actually say this is x cubed over 3 log x squared minus 2/3 of that bit is going to be 2/9 x cubed log x, and then minus 2/3 times the other part is going to be plus 2x cubed over 27. So we get all of that between e and 1, and we now need to put e in and put 1 in. So if we put e in, we're then going to get e cubed over 3 log e squared minus 2 over 9 e cubed log e plus 2e cubed over 27 minus, putting 1 in there, well, remembering that log 1's, I will write it down, but it's 1 over 3 log 1. Well, that goes minus 2 over 9, 1 log 1. That's going to go as well. So the only bit that we'll actually be interested in is the 2 over 27 for that part there. Everything else will have gone. Yeah, that should be okay there. So then this all tidies up when we're doing it. Remember, log E cancels itself out as well. So when we're doing this, a lot of this stuff, that's 0, log E is going to be 1. So I'll give you time to work out E cubed over 3 minus 2, but it actually works out to be 5 over 27 E cubed minus 2 over 27. And then writing that neatly, it's take the 27 out. So it's 5E cubed minus 2. And then just remember, because I didn't have it in there on all of these, there was a pi outside all of this. I don't know where that dropped out. Here, when I was doing this bit there, it's pi multiplied by all of that. So obviously it's pi. So we have our final answer then of being pi over 27, 5e cubed minus 2, and they said find the exact volume. So we know that you've got to leave it in something, that is the answer, but you've got to leave it in something similar to that. So hopefully that all makes sense.